This video is for the chemical activity lab. In this lab, you are going to investigate how certain metals are more reactive than other metals. So for this, I have an example over here. Well, two examples that kind of demonstrate what's going on with that. In these examples, I made up these two made up metals, X and Y. So in this first reaction, this first example, I'm saying I'm taking a solid piece of this made up metal X, and I'm going to add it to an aqueous solution of this metal Y that's bonded to NO3 So for this, when it says aqueous solution, aqueous just means it's dissolved in water. So this is a liquid where it's this solid dissolved in water. And what I'm saying is when you do this reaction, you'll get Y, this solid, precipitate out, and now X will be bonded to this NO3 and this will now be in the liquid solution, dissolved in water. So what happens here is the X, element X comes in and kicks Y out, and X is taking its place. So now X is bonded to the nitrate group, Y is by itself, and since that's a precipitate, it's just a solid that's going to settle out of solution. For a reaction like this, X has to be more reactive than Y. X has to be reactive enough to replace Y. Now, if I try and do the opposite, where I'm just taking a solid piece of this metal Y and adding it to a solution of XNO3 I'm not going to get a reaction there. What it's saying is Y is not reactive enough to kick X out. So nothing happens there. Really what this is saying is the more reactive metal is going to be the one that ends up in the bond. Like here, X ends up with NO3 but here it started off with it, so that's how it's going to stay. So this is all because X is more reactive than Y. So that's what we're going to be investigating with this lab. So when you're doing this lab, what you're going to do is have a weld plate, and you're going to grab three different metals. There's going to be copper, magnesium, and zinc. You put 4 pieces of copper along the top, 4 pieces of magnesium, and then 4 pieces of zinc. When you're working with the copper and magnesium, I think it helps us if you have part of the solid that's going to be out of the liquid, so you can compare what's in the liquid and out of the liquid. And what you want to do is in this first column here, you're going to put, the lab says 8, so about 8 drops of this copper nitrate. This is a liquid. You're going to put them in that first column there. And then magnesium nitrate goes in the second, zinc nitrate in the third, and silver nitrate in the fourth. What I would do is put all those liquids in there and let them sit for a couple minutes so that it has enough time so you can tell if a reaction is occurring. Now we can give you some hints here. And really what's going on is you want to see if copper, in this case for example, copper is strong enough to replace the metals in these solutions. Well, copper is not really going to react with the copper nitrate. If you're saying copper is replacing copper, you're not going to get anything there. So that's going to be no reaction. Just like magnesium and magnesium nitrate, that's going to be no reaction, and zinc nitrate, they're no reaction. But for the rest of them, you should watch these and see if you get a reaction. If you have a reaction, write down what it is. If no reaction occurs, it's fine just writing NR for no reaction. Now another hint is, out of these 3 metals, copper, magnesium, and zinc, one of them will react once, one will react twice, and one will react 3 times. So if you don't get a 1, 2, and a 3 in no particular order, there's something that you're not looking at close enough. We're not giving you silver, right? That's expensive, but we're telling you it wouldn't react with any of these liquids. Silver is pretty unreactive, which is why it gets used in jewelry and stuff like that. Now, after you have that done, you can start answering questions. Now, some things that students miss sometimes, it says similarities and differences in that first question. For question 2, where it says which of the 4 metals reacted, it's referring to these 4 metals, copper, magnesium, zinc, and silver. You want to look across the row and see how many reactions they had. Silver is flat out telling you it didn't react with anything. So out of these 4 metals, silver should be the least reactive. And then you should be able to just follow along with what you did and answer the rest of the questions. Now when you're done, you want to take the tray, hold it over the trash can, spray it out with some water so no metals go in the sink, and then dry the weld plate and put it back up on the front bench. The one thing that it asks in the lab, and it tells you down here, silver nitrate. It says, what are the hazards of working with silver nitrate? Silver nitrate, I mean, if you ingest it, it could be poisonous, but I don't think it should be obvious that you're not supposed to do that. The more common thing is if you get some on your skin, it kind of acts like a dye. You might end up with little black spots on your skin. It doesn't burn. It's not like you're getting a chemical burn. It really just stains your skin for a little bit. So be careful with that. If you get some on your hands, just rinse it off right away, and you should be okay. but that is the chemical activity lab.